In this video, we're going to go over some advanced assembly techniques that will help you with problems that are potentially on the CSWA, as well as problems that we might use to practice for it. So what I'm going to do is there is a set of files to download. You should download and extract those. And at this point, I'm going to go ahead and start a new assembly. The first piece that I'm going to bring in is going to be the base piece. The funny part is a lot of these assemblies are basically simple machines. And so a lot of them will start with some sort of base that we bring in and will be fixed in space. So here's my base piece. I'm going to go to Insert Components. The next thing I'm going to bring in is called the cylinder. When I bring in the cylinder, I'm going to set this down. Now, the way I've designed these parts, and a lot of times the way they're designed, they may use different hole sizes to kind of show you where different parts go. So in this case, this hole lines up with the hole through the base. And then if I bring this out, I can put this face against this face, against this face. There it goes. Okay. Now you can see that this kind of wobbles. And that's not exactly what I want. In the directions that I'm working from, it says the cylinder will remain upright. Okay. Cylinder will stay vertical. So in this case, what I want to do is I have this menu right here in my view window that looks like a little eye. And when I drop it down, I've got a lot of different visibility things that I can turn on and off. So one of the things I want to do is I want to view axes. If you look at it, that doesn't necessarily help me. So I want to view temporary axes. And what this now gives me is you can see I have a single axis that runs through the center of my cylinder. And if I grab that cylinder axis and I grab a vertical edge of my fixed base, I can make those parallel. Another option, I'm just going to undo that last click, is I'm going to grab that and I am going to look at either my front or my right plane because both of them stand up. So I'm going to pick front plane and I'm going to pick parallel. Oh, that doesn't actually help me because I'm not trying to lock it in that direction. So try one more time. Sorry. I want that to stand upwards because even the way it is now, this mate right here makes it parallel to the front plane. So the one I wanted was the right plane as a parallel mate. Okay. And that I can mate that to a plane. Now that doesn't want to go anywhere. It is standing completely vertical. So whether I pick a vertical edge of this piece or whether I pick something that is vertical in the way I want to lock it in, like the right plane, either way, I'm good to go. So that one is locked in. I'm going to bring the next one in. And I am going to bring in the lower arm. I think that's the next easiest one to do. The lower arm goes on the back of the assembly. The easiest mates to do there, and actually the only ones that I need on this one for now, are my cylindrical hole and the cylindrical hole it should line up with, concentric. And then the face of the base and the face of the part should be coincident so that they are touching. Now this one, I do not want it fully defined because I want the arm to be able to move. That's part of this little simple machine assembly that you're going to see we've got going on here. So I've brought in the lower arm. I'm going to go ahead next and bring in the upper arm. So upper arm. This one looks a little different. So I'm going to go ahead and grab the small hole, which will line up with the small hole of the assembly here. And they are coincident, yes. Now, in this case, the back side of this lines up with the front side of this one, coincidentally. Okay, and you can see where that puts it is I had a little standoff on the base that was the thickness of this. So you can see that it lines up like that. Okay, and what's going to happen is there's going to end up being a piece that goes through the slot, attaches to this, and also goes into the cylinder and kind of brings all these parts together. Okay. And in this assembly, that is called the piston. So that's what I'm going to grab next. So insert components, AT piston is what I'm going to grab next. I'm going to bring this in. Now, the first thing I want to do is I'm going to grab there's a very small cylinder edge there that I want to make concentric with that, but I'm going to flip it so it sticks up out of it. Okay. Next thing I'm going to do is you can see there's a edge that is just the right size to go in this hole in a concentric manner. Now, because of those two concentric mates, so some people I think might have been thinking, oh, I need to go back and put a mate back here to line these two up. And actually, because I lined those two circles up, I'm actually good to go. Now, you can see I've got this moving here, but it could still twist or move around. So the last mate, this is actually a new mate type that I'm going to use. And I'm going to grab the cylinder of this piston part here, and I am going to grab one of the flat edges of my slot. Okay. And the mate that I'm going to use is called tangent. So this circle is touching it just at one point. All right. It's the perfect size to fit in that slot, but this tangent mate will basically force it to stay in the slot. Okay. Which means that this can move up and down and the piston moves in the cylinder. Now, the last things that I need, there are two of them, is you notice if this assembly was in reality, it wouldn't stay together. Okay. There's nothing but hopes and dreams holding these two pivot points together. So I'm going to close my mates. I'm going to insert component, and I've got a small bolt. And if you hold control, you can also pick a second one, which is large bolt. And when I pick two of them, I'll click and then I'll click again and bring one copy of each in. So that is a little shortcut if you're going to bring multiple pieces in. These mate in there quite easily. As you might imagine, the cylinder goes with the cylindrical hole, one of the cylindrical holes, and the back side of one of the heads goes against the face of the part that it should be touching. And these are made so that they are the perfect size. And as you can see, they go right through and attach those like they would in real life. So same thing over here, cylinder to cylindrical hole. And face of the part that it would be touching, back face of the bolt. Those are now coincident. We are good to go. So I have my assembly. I have my assembly fully defined, or I'm sorry, in a state in which it can be fully defined. It is currently underdefined because, as you can see, I can move these various pieces. Okay. Now, a little side tip. All right. Um, I can still Casper pieces through it because, again, they act like nothing is there. If you want this to actually stop where it would run into it, if you go to evaluate, there is one, or I'm sorry, if you go to assembly and you go to move component, what you can do is you can turn on collision detection where it will stop at the collision. Okay. So I can now move this up and it stops, and I can move it down and it stops. Makes a little dinging sound. So this is actually it working much more realistically. So I'm just going to put it right in here. So as we use this for some questions, we're going to go ahead and set up a couple of things. The first thing I want to set up is angle A. Okay. Now in the diagram I'm working for, angle A is the angle between this edge and this edge. Okay. And what I want is I want an angle mate. Okay. And you can set that up. And right now I'll set it at 45 degrees. Okay. And that's perfectly okay. Now what I'm going to do, as I've done in previous assemblies, is I am right now going to either right click on it and rename, or I'm going to slowly click in there and I'm going to say set for angle A. So on the questions where I'm told to use angle A as if angle A is blank, what is distance B? That's the angle A that I will set. Okay. Now, right now, I'm going to go ahead and suppress that so I can set up my mate for distance B. Now, distance B is actually inside the cylinder. So it's from the bottom of the cylinder to the underside of the piston, basically the airspace in this gap. As you can see, currently I can't see that. So one of our advanced techniques is to look at our assembly from basically the front. Okay. I don't want an ISO necessarily, because then SolidWorks might pick the wrong direction. But if I look at it basically from the front, but I turn it a little bit because that makes it easier, I've got this one up here that looks like a half-eaten cake. All right. It's called section view. And when I click it, it's going to kind of grab a plane. And in this case, it grabbed the front plane. And you can see it looks like my assembly disappeared. But as I pull this towards me, it starts to hit some of the material and you see them parts coming in. And it's literally showing me what's going on right at this point. Okay. So if I turn on my section view such that it cuts this cylinder open, I can now see the surfaces that I want to create my mate using. Okay. So if I click mate, I can now click the bottom surface there and the underside of the piston. And I want this to be a distance mate. I don't have mine set at what I need to, so I'm going to set it. I'm going to type in 50 millimeters right now. It's going to convert it to inches, and I am going to change my units. There. But now you can see that that is where it is set. So if I again get out of my mates tool, come down here, go to rename, set for distance E. So again, that's the mate that I will use if I'm given distance, this is your distance, what is angle A? Now the nice part is once you've set your section view, you can actually turn it on and off. So I can turn it off there, okay? And just to make sure that if I'm asked for a mass or something like that, or center of mass, I get the right thing. I don't know if that sectioned material will actually affect your numbers, so there's no reason to take the chance. So you just turn that off real quick. And then what I can do is I can edit this and I change it from 50 to 75. You see the piston moves up. And then what I can do is I can look at my assembly from the front view, go to evaluate, measure, make sure I'm using the full size measure one. Again, if you get the small one, drop this down. Okay. I click the bottom edge of this, I click the top edge of this, and it tells me the angle between them is 43.53. There's my answer. Okay. So if I'm given distance B and asked for angle A, that's how I figure that out. If I am asked, so again, to switch, I suppress both of them. I'm going to unsuppress the angle. Again, you don't want both of them unsuppressed because then everything will go red and angry. I'm then going to edit my angle and I am going to go to 37 degrees so that that turns. Now, once I've set the angle, you might go, well, how do I measure the inside? I can't see it. If you turn your section view back on, oh, sorry, I'm in a make command, so I can't just do that. If I turn my section view back on, it goes back to the same place. So then I can measure from here to here. And the distance right here and the change in y, which the y is the up and down direction, they're the same number, but my answer is this 42.88, as is the normal distance. Those are all three the same. All right, and when I'm done, I can go ahead and accept my section. Well, if I accepted my section view, the measure tool would be a little less weird. But then I can go ahead and turn that off as I don't need to, if I need to like set something and then do a center of mass. But those are the types of questions that you will get. I believe in the question set, it does also have you set a coordinate system. So just quickly to review that, it's under assembly, or it's under reference geometry, coordinate system. And if I remember correctly, I believe it has you put it at the bottom edge midpoint. With x-axis being straight up or side to side, y-axis, I can pick a vertical line. It doesn't need to be the vertical line that touches it, just a vertical line. And that's plenty of information for it, especially since it came in correctly. So there you go. If I'm wrong, put it in the place where it indicates, but that's as a reminder of how. You are now set. You can save this assembly and use it to complete all the questions for this activity.